The analogy goes, what if the multiverse, the landscape of string theory, and all the information within it, have a one-dimensional representation of reality as well? If you consider the two-dimensional data and the three-dimensional data as two versions of reality or two reconstructions of the same reality, then why do we not have a third version, or in other words, a third reconstruction of reality in one dimension represented in a straight line? The logic would be the same as compressing three-dimensional data down to a two-dimensional surface. We will consider compressing two-dimensional data down to one dimension. It is highly likely as well that in the process the data would be even further scrambled beyond recognition, unless you know the detailed code. The code is embedded or scrambled in just one dimension, one straight line. In the case of the two-dimensional holographic film, it is required to shine a light on it to form a three-dimensional image. It could be as well the same logic to form a two-dimensional construction from a one-dimensional construction. This light could be literally light waves or photons. It could be in the form of fluctuations or ripples, or even a force that could be added to our currently known four forces. It could also be one of the complex forces introduced in the book The Big Defreeze of the Universe, Analogies and Thought Experiments by Mohammad Hasan Algarhy. The holographic principle tells us that the maximum amount of information in a region of space is proportional to the area of the region. But what if we want to know the maximum amount of information scrambled in a one-dimensional straight line? It would probably be proportional to its length. How could we predict the length of the straight line? Let's borrow the number from the landscape of string theory, 10 to the power of 500, as this would be considered the maximum amount of information of a region in space. This region would be the straight line with all the information in the multiverse scrambled and encoded in it. That is one reason why the number 10 to the power of 500 from the landscape of string theory could be a good candidate for the length of the straight line. Let's take the analogy further for the light that we need to shine on the one-dimensional straight line to form a two-dimensional reconstruction of reality. Let's consider we shine a tiny wave of light on our one-dimensional straight line. Let's consider the wavelength of this light wave is 5 times 10 to the power of -5, which will cause a tiny fluctuation that could be in the middle of the straight line or any other position on the straight line. This tiny fluctuation would be the first identity stem wave or ISW of the supersymmetrical crystal, explained in the first section of the book, The Big Defreeze of the Universe. This light and the resulting fluctuations will not be changing or affecting the geometry of the straight line. The fluctuations would be projected on another space. It will act as a tiny change in the information coded on the straight line, which will be projected on another space. If we followed the logic of this analogy, an inevitable question will come up: who shined this light and why? There must be a force shining this light, and this force has to be continuous and unbreakable. Let's call this force the HD force, or the higher dimension force, which is presented in further detail in the Big Defreeze of the Universe book. Yet, this tiny fluctuation or ripple does not affect the straightness of the straight line. It might not impact it at all. Comparable to the way you shine a light on a two-dimensional holographic film. The three-dimensional images produced do not affect the holographic film. This fluctuation does not lead to a wave in the straight line. It is a reconstruction of reality projected on a different space without affecting the properties of the total space or the straight line. Let's consider this straight line a topological manifold called the total space, comparable to the E topological manifold mentioned earlier. Then would be the projection or surjective map from the total space into the base space, M. The mathematics of the topological manifolds and manifold bundles could be a good basis to understand this approach. In a sense, it would actually be the total space having all the information scrambled in one dimension. If you go back to the manifold bundles explained earlier, the wave function is a section of the C-line bundle over physical space, and from the function, we can construct the section. A point could be projected from the total space or the straight line to the base space. Additionally, a section or a wave function or a map can start in the base manifold M and map into the total space. Such a map is called a section of the bundle. If you can apply the map to go from M up to the total space and then you apply the projection afterward, and if this leads you back to the identity on the base space, then you have a section. To be clear about one of the significant thoughts this analogy is getting at, and without getting too philosophical, is that if we consider our universe, our world is the base space, then simply our acts, our words, etc., which we basically emit in the form of waves, could be mapped in the total space and projected afterward on the base space, and we can measure it. We would be basically participating in coding the information on the one-dimensional scrambled straight line which might be going through, or having a two-dimensional reconstruction as well. In principle, the reconstruction could be in more than 3 dimensions as well. Back to our small ripple with a wavelength of 5 times 10 to the negative 5, which is just a number for the purpose of the analogy. In this phase, the universe is in a heat-death state comparable to what will happen in the big freeze scenario. Actually, more accurately at this phase, there was no heat yet, there was no energy yet, so probably we should call it a preheat state rather than a heat-death state. The Fourier transform will take it from here. The reason is that the Fourier transform would be our mathematical machine to decompose all the frequencies of information scrambled in that straight line and the supersymmetrical crystal. Additionally, if we worked it out the other way around, it could explain how this information was composed in the first place. At least for now, this will apply to the ISWs, the identity stem waves of our supersymmetrical crystal. The Fourier transform would help us understand how these ISWs were composed and coded in the first place. The first identity stem wave, ISW, would be our first signal with a given frequency of 10 to the negative 5. It's just a number for the purpose of the analogy. At this phase, time and space are one thing, so we just represent them by a number, 10 to the negative 5. Since we have a given frequency for our ISW, our mathematical machine will start treating it differently. Let's graph this frequency at a finite portion of space-time. Then take this graph and wrap it up around a circle. It could be considered as a rotating vector where the length of each point in spacetime is equal to the height of that graph for that spacetime, which would be equal to 10 to the negative 5 in our case here. High points of the graph correspond to a greater distance from the origin, and low points end up closer to the origin. So moving forward 10 to the negative 5 units of spacetime would correspond to a single rotation around the circle. So here we have two different frequencies at play. There is the frequency of our identity stem wave ISW, which is 10 to the power of minus 5, and then separately there is the frequency with which we are wrapping the graph around the circle, which could be half of the rotation per spacetime unit. The winding frequency at this phase matches the frequency of our signal, 10 to the power of minus 5. All the high points on the graph happen on the right side of the circle, and all of the low points happen on the left. Remember that the identity stem wave ISW is the BC or quantum wave of the smashed and shattered elementary particle. So, as the first ISW starts to fluctuate, having a frequency and winding, this would create energy or heat, and would stimulate the creation or formation of other ISWs, which will have different frequencies, and will start winding as well. Here, a center of mass would start forming. As we add more frequencies and the graph winds up differently, that center of mass kind of wobbles around a bit. And for most of the winding frequencies, the peaks and the valleys are all spaced out around the circle in such a way that the center of mass stays pretty close to the origin. It could get complicated though when the sum of the winding frequencies is equal to the sum of the signal frequencies. The center of mass is expected to move far to the right. If we plot it on a graph, it would look like a spike. We will want to keep track of where the center of mass is for each winding frequency. When a certain frequency persists for a long time, then the magnitude of the Fourier transform at that frequency scales up to more and more. The longer that signal persists, the larger the value of the Fourier transform at that frequency. For other frequencies, even if you increase it by a bit, this is cancelled out by the fact that for longer time intervals you are giving the graph more of a chance to balance itself around the circle. The frequencies of these identity stem waves, or ISWs, are comparable to the temperature at which they form Bose-Einstein condensates. The Big Defreeze of the Universe book suggests that for the ISWs of all matter, the winding frequency is comparable to the ISW's frequency except for helium. The winding frequency is expected to be 299,789,000 12 times the frequency of helium's ISW, which suggests a symmetry-breaking mechanism, a mechanism that breaks the symmetry of the supersymmetrical crystal, leading to an explosion or a big bang with a value comparable to the speed of light.